Hey, what's up everybody? In this video we're going to go over bubble sort, a sorting algorithm in JavaScript. Before we get started, I just want to point out, if you want to see bubble sort visualized to kind of get a better idea of how the sorting algorithm is working behind the scenes, then you'll want to check out the YouTube links that I have in the description of this video. This video right here is a CS50 video, and it actually explains everything you need to know about bubble sort conceptually from someone who's really smart and knows a lot about it. So you might check this one out. I'll link it in the description. Meanwhile, if you want to see a visual, I've sped this one up to 16 times speed, and basically it's just Legos, and you can see the height of each one of these stacks is either smaller or larger than the other, and these three little Lego characters are sorting these different stacks to get them from smallest to largest. So go ahead and check that out. I'll put the link down in the description below. And then lastly, if you want to learn a little bit about big O notation, which basically talks about the speed of the algorithm as the input grows, then go ahead and check out any one of these videos. I can link to the search result. Obviously, just search for Big O Explained Simply. This video is not about Big O notation, so I'm not going to go into it. If you want to understand those concepts, there's some really great videos here, so go ahead and check those out. Okay, so here in our code, I'm using CodePen just so we can see everything happening really quickly and easily. And I'm going to go into the settings of CodePen, and in the JavaScript tab, I'm going to enable Babel so I can use the latest syntax with JavaScript. If you don't know ES6 syntax, then go ahead and check out the Learn ES6 playlist that I have on my channel. I think the main video I have in there is from Derek Banis. It's like a Learn ES6 in one video kind of thing. There's a ton of free resources out there for ES6. That's one of the better ones in my opinion, but there's a lot of them and most of them are pretty good. I will be explaining what I'm doing as I'm writing this code, so if you don't know ES6 yet, don't worry about it. You should still be able to grasp these concepts. Okay, so the first thing I've done is I'm going to try to make this a little bit bigger without running out of space. I have written out pseudocode, or I just basically wrote comments explaining what we're going to do. And before we do that, I'll briefly explain how bubble sort works. So we have an array, let's say 1, 4, 6, 3, and 0. And we want to sort this so that it ends up being 0, 1, 3, 4, and 6. Basically what happens is we start with a outer loop that's going to loop over each one of these elements in the array, and as it goes through, let's say it starts at 1, it's going to do an inner loop that also loops over all of the elements in the array, and that inner loop is going to compare all adjacent or side-by-side elements. So for the first value, then we loop 1, 4, 6, 3, 0, and what we do is we compare 1 and 4, and we say, hey, is 1 bigger than 4? The answer is no. Okay. Then we go to 4, and we say, is 4 bigger than 6? No. Okay, it must be in the right spot. And then we say, we go to 6, and we say, is 6 bigger than 3? The answer is yes. Then we need to swap those two, so we perform a swap, and I'll show you how to do that in the code. And now we're here, we say, is 6 bigger than 0? The answer is yes, so we swap those. And now we've done one full iteration of the inner loop, and we've done one full iteration of the outer loop. So in the outer loop, we move to 4, and then we start over again. We say, is 4 bigger than 3? Yes. Okay, so swap those two. Is 4 bigger than 0? Yes, so we swap those two. Is 4 bigger than 6? No, so we leave them in the same place. And this just keeps happening until all the values have been swapped into the appropriate places, and you end up with 0, 1, 3, 4, and 6. So now let's actually write the code to be able to perform this sorting algorithm called bubble sort. So I'm going to get rid of this code right here, and the first thing we want to do is define an array to be sorted. So if you're coming from ES5, then you would use var to create an array. We get a variable here, we'll call it r is equal to, and then we have an array literal. We're actually going to use the ES6 syntax, so we'll use const instead of var, and so we have const r is equal to, and now we just want an array of numbers that are out of order. So we will do something like 4, 5, 1, 0, 2, 6, 9, 7, 8. So once this is sorted, we'll get 0 through 9. So now that we've defined the array, we need to define the sort function. So if you're coming from ES5, you would do something like function sort and then there's your function that you're defining, and it would take an array as the argument. In our case, we're going to do something like const sort is equal to an arrow function. So this is the ES6 syntax again. And then inside of here is where we have all this logic. So we can put this inside of here. And basically what it's saying is loop over the array. That'll be the outer loop. And then inside of that loop, we're going to loop over the array again. That'll be the inner loop. And then within the inner loop, we're going to compare the current inner value with its adjacent value. And if the value on the left-hand side is larger than the value on the right, then we'll swap them. Then after both loops are finished running, we return the sorted array. So let's go ahead and start with the outer loop. I'm going to go ahead and do a for, and then you normally would do a var I. If you're going from ES5, we'll use the let syntax, so let I is equal to 0. That is for ES6. And then we'll do I is less than r.length and I++ for the iterator. And then inside of there, this is the outer. Now we need the inner, so we'll do the same thing. I'm just going to copy this and paste it in. And except now for the inner loop, we don't want to use I again, so we use j. And we can say j is less than array.length, j++. And since I is going to be starting at 0, and then we're going to loop through all of these, and we want to check 5 against 4, we'll start j at 5, and then to get 4, we'll do a j minus 1. So we'll start j at index 1, because arrays are 0 base index, so we have 0 here, and then 1 here. So if we want to start at 5, we use 1, and then I'll show you in a minute how we use j minus 1 to get back to the first value in the array, or the value to the left of j. So now we want to compare the current inner value with an adjacent value. So we'll say if, and we'll do r j minus 1. And so what this does is 1 minus 1 is 0. It gives us 4, and then j will be 5. And we'll say if this value, the value on the left, is larger than the value on the right, so r j, and that would give us 5. So if 4 is larger than 5, then what we need to do is the logic to swap those two values. So if we're going to swap these values, we need to use a temporary variable to store one of the values, so we can swap the right hand to the left side and then still have access to the left side to swap it to the right side. So we will create a temporary variable, let temp is equal to r j minus 1, and then we will do r j minus 1 is equal to r j. Now where j minus 1 was, we don't have access to it, except we do because we stored it in the temp variable. So now we can say r j is equal to temp. So if you see what we're doing here is this would be j and this would be j minus 1, and if they needed to be swapped, in this case they don't, but let's just say that the 5 is on the left hand side and the 4 is on the right hand side. Basically what we're saying is go ahead and take the 4, store it in a temporary variable, take the 5, put it in the place of the 4, take that temporary variable and put it in the place of the 5, and so we end up with 5 on the left side, 4 on the right side, which is kind of a bad example because we want all the larger values to be on the right side. But you'll see it as we get to some values like, let's see here, 9 and 7. So we would want to store the 9 as the temporary variable, and then we would take 7 and put it in place of 9, and then we would take that temporary variable and put it in the place of the 7. So getting back down here, now when all this is done running, we want to go ahead and return the sorted array. So if we go for, and let's see here, we've got an if statement, so that closes here, and then the inner for, and then the outer for. And so when the outer for is done running, then obviously the inner for is done running as well. And so at this point we can return the array, which will now be sorted. And if we want to see the output of this in the console, then we can do something like console.log, and we'll do a sort of array. Just so happens that the argument array is the same as the array that I created up top. We can call this something like out of order array, and actually let's shorten it, unsorted array. So we'll copy unsorted array and we'll pass it into the sort function, and then what will get logged to the screen will be the sorted array. So if everything's running how it should, then we can go ahead and save this and run it, and we should expect to see 0, 1, 2, 4, 5, 6, 7, 8, 9. The only thing I missed is I didn't put a 3 in there, so we can put a 3 at the very end here. Save it, clear this out, run it again, and now we get 0 through 9. Okay, so that's the array sorted. Now let's talk a little bit about how we can optimize this. So the worst case scenario for big O notation of this setup that we have here is going to be O n squared. And the reason that is because we have 10 values here, and this array has to iterate 10 times to cover all those values. But we have to iterate 10 more times per value because of the inner array. So we do 4 and then we run through the whole array, and we do 5 and we run through the whole array. And so the time complexity for this is going to be the length of the array, in this case 10, squared. So the complexity is always going to be 100. Now there is a way we can optimize that. We're going to do that here in a second. And the fastest possible complexity that it could have would be O sub n, meaning it would run 10 times because there's 10 values. And so the only reason that would ever happen is if the array is already sorted and it goes through once in the outer and it realizes I don't need to sort this thing in the inner because everything's in the right place, and so it ends the function and you only have 10 iterations. So the first thing we want to do is create a counter so we can count how many times we're iterating and we can see what the overall complexity is. So I'm going to do something like let counter equal to 0, and so every time we do a iteration in the outer loop, then we're going to iterate the counter value, and then any time we do an iteration in the inner loop, then we're going to iterate the counter some more. And then ultimately, right before we return the sorted array, we're just going to console.log. I'll just put the word counter in here so we know what it is that we're looking at, and then we'll put the counter variable, and it'll tell us how many times it iterated. So like I said, this is going to be O sub n squared, therefore it's going to be 10, which is n is the length of the array, and it's going to be 10 squared, which is 100. So if we clear this out and we run it, we can see the counter was 100, and then here's our sorted array. So how can we make this faster? Whenever the array is completely sorted, the inner array will never swap, because if it's going through the values and none of them need to be swapped, that means that the array is completely sorted. If for whatever reason the array was sorted before the entire outer loop was done running, then we could go ahead and end the function early. So in order to do that, we need to track whether or not the inner loop had any swapping occurring. So what we can do is here underneath the counter, we can create a variable called isSwapped, and we're just declaring the variable. Right now it's undefined, and then in a moment we'll give it a value. So down here in the outer loop, every time we iterate over each one of these values in the outer loop, we're going to go ahead and set isSwapped equal to false. Now on the inner loop, if a swap occurs, then we want to go ahead and set isSwapped to true, answering the question of whether or not it was swapped. And then what we can do is we can check to see if a swap occurred, whether or not that variable is true or false. And if no swap occurred, then we know that everything's sorted and we can go ahead and return out of the function early. So here inside of this if statement, we know that if this block gets executed, then the value for j minus 1 is greater than the value for j, and therefore a swap needs to occur. So what we can do is say isSwapped is equal to true. Now we need to find a way to check whether or not a swap occurred in the inner loop once we get to the next iteration of the outer loop, and if no swap occurred in that last iteration of the inner loop, then we can return like I said before. So right here is where the inner loop ends. So we can do an if statement, and we'll say if isSwapped is equal to false, or a shorter way of writing this is just putting a bang at the front of it. So we're doing the opposite of whatever isSwapped is. If it's true, then it's false. The if statement will not run, but if it's false and the opposite of that is true, then the if statement will run. So if it does run, meaning it's false, opposite of false, true, then that means that we are completely ordered at this point. We're sorted, and we can return out of the function early. So what we'll do is return the array. And since we're not making it down here to this part of the code, then we want to go ahead and move this portion, console log counter, up here. That way it gets logged here before this gets executed, if it gets executed. Otherwise, it still gets logged out, and then we just return down here whenever the array is completely sorted the normal, longer way, which is O sub n squared. Okay, save this, and at this point, we should be able to see that this has a smaller counter, so less complexity, and runs faster. So if we save it and we run it, now we're getting back, so it's telling me 10, 20, 40, blah, blah, and then the final one is 70. I actually put this in the wrong place. So what we would have to do actually is leave this here, right? And then also put one here. So if for whatever reason it's already sorted, then we can go ahead and log what that counter was. Otherwise, if it has to go all the way through to the end of both iterations, then we'll just log it down here. So normally I don't like that repetition, and I could probably find a way to get rid of it, but for the sake of simplicity, I'm just going to leave it there for now. So I'm going to save this, go ahead and clear this out to give us some space, and run it again. And now the counter is 70. So at some point after 7 iterations, it decided, oh, I don't need to iterate anymore because I'm completely sorted. So if we go back up here and look, so one way we can visualize this is we can go ahead and console log the array for each iteration of the outer loop. So let's find where the outer loop ends. So we have the 4 here. This is the closing bracket for the outer loop. So right before it ends, we'll just do a console log and then R, and we can just call this array, and to keep things consistent, we'll use single quotes. Okay, so now if we run it again, we should see the array for each iteration of the outer loop, and we'll see how it's being sorted. So if I clear this out and I run this, and we can go ahead and move this up here. So you can see here's our original array, 4, 5, 1, 0, 2, 6, 9, 7, 8, 3. Here on the first iteration, you can see that the 1 and the 5 were swapped, and then the 5 got swapped all the way down here to the middle, and then we have 6, 7, 8, 3, 9. So the 9 made its way all the way to the end. So you have the 6 iterations, and then the final iteration that realizes that everything's sorted, and then it gives you 70. So let's go ahead and get rid of that console log to clear up our output here. So I'm going to go ahead and remove that, save this, and run it. And what I want to do is clear this, and now what I want to do is show you what happens when the array is already sorted. So we'll just do const sorted array is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think that looks correct. So what we can do is take sorted array, and we will put it inside of the function call. And so now if we save it and we run it, what do you think the count is going to be? Okay, so hopefully you guessed that the count is 10. So we run it, and you can see that the counter is 10, and that's because it did the initial inner iteration of the on 0. It did 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it realized that it didn't need to sort anything, so it just has those 10 counts, and it goes ahead and logs out the array, or returns the array and logs out the counter. So that's the fastest possible situation that we could have. And then the average situation is going to be the n squared, which is the 100 that we saw. And then if you optimize it with this is swapped right here, then you can end up anywhere between O sub n and O sub n squared. So let's go ahead and do one further optimization before we end the video. And what we're going to do is take this logic right here for swapping out these values and put them into their own function. Right now we have the temp is equal to array j minus 1, and then j minus 1 is swapped with j, and then j is swapped with temp. So we can take this logic right here and we can copy it, or cut it rather, and then we're going to put it into its own function. So we can say const, and we'll call this function swap, is equal to a function that takes an array and then a value for I and a value for j, and then we can do the, don't forget your fat arrow, the brackets here, and we'll paste this information in here. And what we want to do now is make it reflect the values that we have coming in for the parameters. So if we have I and j, then j minus 1 is going to represent I, and then j will still represent j. So we'll say I, and we'll call that I. And so now we're saying we get two values in. I is on the left hand side, j is on the right hand side, and we want to swap those. So we create a temp for I, we set I on the left to j, and then j on the right equal to I, which is now the temp. And so in order to do this, we go down here and we just say swap. And so remember, the value for I is the same as j minus 1 in this case. So we'll say swap, we'll pass in the array, and then we'll say j minus 1, that's I, and then we'll say j, that's going to be j. And now it's going to execute this function right here. When this gets invoked, the swapping occurs, and down here we set is swap to true, and then we continue on with the rest of the iterations for this loop, and then back up to the outer loop, and then this sort function ends, and when it ends we go ahead and return the array. So that's it. We can save it real quick, clear this out, and I'm going to go ahead and put this back as the unsorted array, save it again, and run it one more time. And so here it is, counter of 70, and if you wanted, you could play around with these values up here, so I'll comment that out. And so if I take the 1 and replace it with, let's say, the 3, so I'll put the 1 at the end and put the 3 here in the beginning, and we run this, you can see that the counter has upped to 90, so this one's a little more complex than what we had before, which was 70. And that's it. You can keep messing with these values, swapping them around to see like what the less times it has to be sorted, then the less complex it's going to be. Anyway, you can fool around with that if you want to, but this is the basics of bubble sort. Again, if you want to check out a really detailed explanation of it, then check out this video. And then the Lego bubble sort is going to be a nice visual of it. So let's run through that one more time real quick. I'm just going to replay it, 16 times speed. And so you can just see they're swapping the bigger ones to the right, which makes the smaller ones move to the left. And at some point, they're fully sorted. So that's what we just did with these numbers, 0 being the smallest, 9 being the largest. And then if you want to understand everything I've been talking about this big O notation, if you don't understand it already, then go ahead and check out some of these videos. This first one here is actually by the author of the Cracking the Coding interview, so it's pretty good. Okay, so that's it for bubble sort. I'll go ahead and put the source code or the link to this code pen down in the description, and we'll see you in the next video. Thanks a lot.